Hi, fourth grade math. I hope you guys are doing well. The last time that you should have completed a math workbook page, you were completing the Units 1 through 7 review. Unit 7 was all about decimals. We learned how to add, subtract, multiply, and divide decimals. We learned how to convert fractions to decimals, etc. This unit, Unit 8, which we are starting today, is all about congruent and symmetric figures. I know you know the word congruent because of our simple solutions lessons. So this lesson is kind of a review to get us ready for symmetric figures and to get us ready for creating tessellations. Okay? Our objectives today, we're going to define the word congruent in our math terms. And then we will find shapes that are congruent to each other. The materials you will need your math workbook 4B and a pencil. You will need these attachments that I've sent to your parents. It's just our usual Smartboard lesson printed out and simplified a bit. And that is all. You know, I always like to start off our lesson with a hook. I want you to pause my video and think about what the word congruent means based off of what you already know from Simple Solutions. Okay, if you have your answer, you know that two congruent shapes, are shapes that are the same size and the same shape. They must be identical. So, are these two figures congruent? At first look, you might say, no, Miss Weinbarger, they are not congruent. They don't look the same. Well, what about now? What if I put one behind the other? These two shapes, my note cards, are congruent because they are the same size and the same shape. What if I cut one in half? Same shape? Yes. Same size? No. Are these two figures congruent? No. They are similar. They are similar, what we call in math. Okay? Today, you will be given figures that are not so simple as rectangles and normal quadrilaterals. You will get some funky-looking irregular polygons that you will have to decide if they're congruent or not. Oftentimes, they will put them in odd positions so that you might not be able to tell their congruency. Sometimes you might need to measure using a ruler to figure out if side A is congruent to side B. Okay, take out your Smartboard slides. Unit 8, congruent and symmetric figures. Okay. Sometimes we have to turn shapes or rotate or flip shapes to see their congruency. Look at example 1, yellow triangle versus green triangle. At first note, you might say, nope, they're not congruent. If you turn the vertex in shape green and you rotate it, you will find that these triangles are congruent. Look at example B. I have a pentagon, an orange pentagon and a purple pentagon. If I flip the purple and I flip its vertex all the way around, I will have congruent pentagons, same size and same shape. And then finally, example C. I have a green semicircle, which is how many degrees? 180. Protractor, half of a circle. And I have a blue one. One's upside down, but they are in fact still congruent. So sometimes you might have to manipulate, turn, flip, rotate the shapes to see their congruency. Okay? So if they're in a different position, it doesn't mean they're not congruent. You just have to check and see. All right, so here's our definition of congruency. And ignore the look back on page 74 because we don't have our textbooks currently. The pairs of shapes that we just identified as being the same size and shape are known as congruent shapes. Here's a blast from the past. Remember our geometry unit? Let's review our symbols. We have two triangles. And what kind of triangles do you think these are? Equilateral, isosceles, scalene? If you said isosceles, you are correct. Okay? I have one triangle, LMN or MLN, that is looking straight at us. And I have another triangle that's kind of rotated a bit. It's on its side. And this triangle is triangle SRT. Do you remember what these little tick marks mean? If it has a tick mark, it means that this side is equal to or congruent to the opposite side. Okay, so line LM is congruent to line LN. Over here, we have SR, 12 centimeters, and RT, 12 centimeters. That means they are congruent. Very good. Now, if it has a double tick, that means that line is not congruent to either side. We also have our angles that are labeled in triangle SRT. We have 60 degrees and 40 degrees. Okay, so we have to decide if these two triangles are indeed congruent. You can use a ruler, if we needed to measure them. All right. And then finally, the bottom, we forgot to label 5.6 centimeters at the bottom. Okay. So, if I know that these two triangles are congruent, then I can answer these questions. Answer them with me. Angle A is equal to angle R. Very good if you got that correct. Letter B. Line MN is congruent to line ST. And I will write the answers in a bit. And letter C, ML is congruent to LN, which is also congruent to, you could have said, SR or RT. So let me write down the answers and you can copy them down. Angle A was congruent to angle R. Line MN is congruent to line ST. And ML is congruent to LN, which is also congruent to RT or SR. Here are the answers. You can pause if you need to put those in. So, once I've concluded that my lines are congruent, my angles are congruent, then triangles RST and LMN are indeed the same. They are equal, they are congruent. Okay, now that we have that, we're going to look at some irregular shapes on page 83 of your workbook. If you need some time to get there, go ahead. Now, not all of these shapes have an equal pair. Let's do this together. Let's start with triangle A. Take a good look at your page. Is there a congruent figure to triangle A? If you need to back up a little bit to see the congruency, you may. I see. Triangle A is congruent to triangle G. Write A and G as your first pair. Okay. Let's check out B. Is there a shape that's congruent to B? If you said C, you are correct. B and C are congruent. All right. Look at D. Is there a figure that's congruent to D? Yes, that is E. D and E. Now, you might say, but Miss Weinberger, look at F and H. That's kind of the same shape. They're both parallelograms. Well, F is larger than H. And if you're really stuck, guys, you can count the dots, and you can also use a ruler if you wanted to measure each size to be exact. Flip the page. This page, page 84, they give you some very irregular polygons. You are going to draw a figure congruent to the given one, but in a different position. Okay, so they did the first one for you, and they flipped it. You are also going to do that for A, B, and C on your own. Whoops. And sometimes what's really helpful is if you have tracing paper at home, go ahead and use that tracing paper to help you. If you don't, you can simply count how many dots are connecting them if you'd like to do so. Okay? And then we're going to do 85 together. A, B, C, D, E is congruent to F, G, H, I, J. However, they are not in the same position. So I, as a mathematician, have to visualize and rotate this figure so that it would be similar position to this shape. Okay, so vertex, I'm having a hard time with this book, aren't I? Vertex A corresponds to vertex blank. That means the vertex that's in the same position. So if I rotated that shape, vertex A would be the same as vertex, what do you think? Vertex F. Go ahead and write F. Okay. Side BC corresponds to side, you should have GH. Okay. Side HI corresponds to side CD. CD. Vertex G corresponds to vertex B. And finally, side DE corresponds to side, you should have IJ. Okay, here are all of our answers. F, G, H, C, D, B, and I, J. Okay, very good. Our next lesson is going to be on tiling patterns and tessellations. And in order to create these, we must have congruent shapes. So that's why we did that lesson as kind of a review to refresh your memory since we've been out of school for quite some time. Okay, so let's see if we met our objectives. Did we define congruent? Yes, we did. Congruency means shapes, pairs of shapes that are the same size and the same shape. They can be in different positions. Objective 2, did we find shapes that are congruent to each other? Yes, we matched them in our workbook. And your final assignment was to do this page by yourself. Remember? To create a congruent shape but in a different position on page 84. All right, class. I know that was kind of short and sweet, but it will not be so short and so sweet as we get to our tessellations. Okay, and let me show you an example of what we will be doing in our next math lesson. These are tessellations. These are some examples from students in the past. Pretty cool, huh? All right, so that's what we'll be working on coming on up. I hope you have a good rest of your day. Sayonara.